Okay, so for 1a, we have f of x equals 1 plus x squared between the points x equals 1 and x equals 5. So our equation, which is f of b minus f of a all over b minus a, which is average rate of change. We're going to have to find out what f of 1 and f of 5 are. So f of 1 is equal to 1 plus 1 squared, right? All you do is you plug 1 in everywhere you see an x, and then make sure you always have parentheses, because if you have a negative value or something, you're going to, you need parentheses when you square it. So just always use parentheses. So this is equal to 2. And then f of 5 is equal to 1 plus 5 squared, which is equal to 26. All right, so now we could use our average rate of change formula, use these, the 2, the 26, the 1, and the 5. So I'm going to do f of 1 minus f of 5 all over 1 minus 5. So f of 1 is 2 minus f of 5 is 26 all over 1 minus 5. So then 2 minus 26 is negative 24 divided by negative 4, and that equals 6. So that's your final answer. And this one is not a word problem, so we don't have to worry about our units. Any questions?
So you automatically just square the 1 and 5? Sorry, I'm just like a little confused.
So what I was doing here was plugging my 1 and my 5 into this equation. So that's why they're getting squared, because the equation has x squared.
Oh, so the one just... Oh, I get it. Sorry.
That's okay. Yeah, so what I'm doing is I have the x point. I'm just trying to find the y value on the graph. So where's y is what I'm trying to figure out. All right, and then we'll do c together as well. So g, we have g of t is equal to 1 over t between t equals 1 and t equals 3. So let's figure out what g of 1 is, which is 1 over t, which is 1 over 1, which equals to 1. And then, ooh. All right, and then g of 3 is equal to 1 over 3. So then using this, we have f of, it doesn't matter if I choose 1 or 3 first. I'm going to choose, or sorry, g, not f. G of 3 minus g of 1 all over 3 minus 1 is equal to g of 3 is equal to 1/3 minus g of 1 is equal to 1 all over 3 minus 2 is 1. 3 minus 1 is 2. Okay, so we have negative 2/3 divided by 2. And in case you forgot how to divide by fractions, this 2 is actually over 1. So what you do is you keep the first one, negative 2 divided by 3 times the reciprocal, flip this, times 1 over 2, which is equal to negative 2 over 6, which is equal to negative 3. Negative 3. 3 negative 3 is 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 negative 3. 3 negative 3 Any questions on that?
Isn't that negative 1/3?
Oh, shoot, yeah.
Sorry.
Yep. That's okay, no. So negative 1/3. Any questions?
I have a question. On the first one for b minus a, it was 1 minus 5, but like, how do you know which one's b and which one's a?
It actually doesn't matter as long as whatever you subtract from the top, like whatever point you choose to be A and B, just keep it consistent with the bottom.
Okay.
Good question though. All right, we're gonna skip number 2 and we're gonna move on to problem 3. So let C of T be the amount of caffeine in milligrams remaining in the body T hours after drinking a cup of coffee. Below is the graph of the function C of T. Here it's important to know that the units for average rate of change is the units of the Y value per unit of X value. So in this case, it's the milligrams of caffeine of remaining per hour after drinking coffee. Okay, so that's the units we have to use. So whenever there's a word problem, this is an applied course. You always have to have your units. On exams, you lose points if you don't have your units written out. So get into the habit now. A lot of you on section 1.2 or 3, I forget which one, lost points on that graph because you didn't label your axes. So this is an applied calculus pre-calc course. So the units do matter. It's not just numbers that we're worried about. So question A, estimate the average rate of change between t equals 0 and t equals 5. Give units with your answers. So t equals 0 is here, obviously. And this is my point where t equals 0. So we're at 0, 96. And then t equals 5. We're at 5, 48. All right, I'm going to call this one A and this one B. Actually, I'm going to flip that. This one A and this one B. The only reason I flipped it is because it works either way. I just would rather do 96 minus 48 than the opposite. So let's do our f of b minus f of a all over b minus a. So f of b is 96 minus f of a, which is 48, all over b, which is 0 minus 5. So 96 minus 48, let me do that quick. It's 48 divided by negative 5. It's not going to be a nice number. It's negative 9.6. So this means that negative 9.6 milligrams of caffeine remain after or per hour on the interval. So it's important to know that well, I'm not going to write that, but it's important to know that when we're taking, right, like this rate of change is going to be different than this one, which you're going to see in a minute, because this one is steeper. They're both negative, so we keep losing caffeine in our body as hours increase afterwards. But here we lose more caffeine per hour than we lose here per hour. Right, and you're going to see that in a minute. But it's important to know when you're writing your units, so milligrams of caffeine remaining per hour, you don't have to specify it, but I just want to make sure that you know that it means only on this interval.
I have a question.
Yes.
I'm just confused as why we'd say like remain per hour. Like, would it make sense if we said like you lose 96 milligrams of caffeine within the interval?
You could say you lose 9.6 milligrams of caffeine per hour in that interval. So it's still per hour. Yeah, you could write this different ways. I'm just trying to write it so that my Y units come first and then my X units, just so that you guys get in the habit of knowing that it's always Y over X, Y per X, Y unit per X unit. But
Okay,
you could
thank
write
you.
it any other way that makes sense to you. Good question, then. All right, B. Estimate the average rate of change of C of t between f of 10, or t equals 10, and t equals 15. So those are my points. We have 10, 24, and 15, I don't know, let's say 12. Okay, so we'll call this B and this one A. F of B minus F of A all over B minus A. So we have 24 minus 12 all over 10 minus 5. 15, which is equal to 12 over negative 5, which is equal to negative 2.5. So milligrams of caffeine. So actually, I'll write it. Never mind. Milligrams of caffeine remaining per hour. Okay.
I was wondering, how did you get 2.5? Because when I do that calculation, I'm getting 2.4. I might be wrong though. I'm probably wrong.
I wouldn't jump to say that you're wrong. It's 2.4. You're correct. I was obviously rushing when I made my answer key, so I did not go through it thoroughly, I guess. Thank you. All right, and then C. Compare the magnitudes of your answers in A and B. Can you explain the difference in what you see in the graph? So it's pretty much what I explained before, but the magnitude of the value in A is larger because the graph is steeper. It is decreasing at a faster rate. Great. On the interval, in part B, the graph begins flattening. Out. So here, this graph begins flattening out, which is why, so we're still losing caffeine, but we're losing it at a slower rate because there's less to lose. I'll give you guys a second to write that down. That's a lot. Any questions in the meantime? All right. Problem 4, we'll just do part A together. Kind of went over this before. Part A. Is the average rate of change between t equals 0 and t equals 3 positive or negative? Well, let's see, oops. T equals 0 is here and t equals 3 is here. This graph is increasing, so it's positive. The graph is increasing. Any questions on that? Okay, problem 5 is about studying for this class. I'm going to let you do that one on your own, but we are going to do problem 6 together. No, you don't have to draw that out. You could just, all you need to do for this is the state if it's positive or negative and why, and the why is because the graph is increasing. No need to redraw the graph. Okay, problem 6. Worldwide sales of passenger cars have been fluctuating between 2012 and 2019. So we're asked to find the rate of change between a couple different years. Calculate the average rate of change in sales of passenger cars between the years 2010 and 2017. So 2010 is here, 2017 is here. So these are our points, right? We'll call this one A and this one B. So F of 2017 minus F of 2010 all over 2017 minus 2010 is equal to, well, F of 2017 is 70.69 minus 55.82 all over 2017 minus 2010. Which is equal to, if you subtract this, you get 14.87 divided by 7, which is about equal to 2.1243 cars sold, millions of cars. Millions of cars sold per year. Any question on that? Okay. Moving on to B then. Okay, moving on to B. Calculate the average rate of change in sales of passenger cars between the year 2017 and 2019. So our points here is 2017 and then 2019. So we'll call this one B and this one A. So we have F of 2019 minus F of 2017 all over 2019 minus 2017. F of 2019 is 64.34 minus I don't know if you guys could hear that. My Echo just heard something and made some calculation for me. And then we have F of 17, which is 70.69 all over 2019 minus 2017 is 2. If you do out this numerator subtraction, you end up with negative 6.35 divided by 2, which is equal exactly to negative 3.175 millions of cars sold per year. Any questions on that one?
Since it's negative, would you just say like it's a deficit, like 3.175 million deficit of cars sold per year?
So because there's a negative, like since we have the sign there, we never have to say if there's an increase or decrease because the sign covers that. So we know by looking at it that we're losing, that the amount of cars we're selling is going down because it's negative. So we don't have to put it in our units.
Okay, thank you.
Yep. Any other questions though? Okay. For C, in what 1-year interval was the average rate of change negative? I think I was supposed to write this as 78.68. I think I typed that out wrong. But the 1-year interval where the average rate of change is negative is from 2017 to 2018 or 2018 to 2019. The reason is because I bet I typed that out wrong. So there's 2 years where the number of sales is going down. Any questions on anything?
Did you Oh wait, never mind.
All right, so that's all we're doing together. The rest is for you guys to do, so you guys can go ahead and start working on that. And it's due by 11:59 tonight, as usual. So let me know if you have any questions.
Quick question.
Sorry, I didn't realize I was muted. Yes.
No worries. For problem 5A, so would 0 and 80 be like on the top of like when you start doing the equation or the bottom?
So 0 and 80, the number of minutes studying is the X. So that's going to go on the bottom.
Okay.
The course grade is your Y value.
Okay. Thank you.
Mhm. So for 5A, I'll just show you guys, it's, it's this, oops. It's the same exact concept of this table where this is your X and then the second row is your Y. So here, minutes studying is your X and course grade is your Y. So you're gonna set it up the same. You would have, let's see, we have this point here, 0, 40, and then we have 80, 83 as the next point. So G of pick A and B, we'll make this A and B. So G of 0 minus G of 80 all over 0 minus 80 is equal to 40. So this is G of 0, 40 minus G of 80, which is 83 all over 0 minus 80. And then go ahead and subtract that and divide that through. And then your units here is the, this one's kind of weird to word, but you could word it something like the change in grade per minute studying. And I'll know what you mean.
Sorry, but where did the 0 minus 8 come from?
Sorry, 0 minus 80,
Oh,
my X values. I just didn't write the 8. I mean the 0, sorry. So problem 1B is it's exactly the same as problem 1A. You're just going to use -3 and 0 instead. So you're going to find f of -3 and f of 0, and then set this up with -3 and 0 and solve through. Does that help, Anna? If you follow this one as literally as it's written here, you'll get the right answer as long as you put at -3 inside the parentheses and 0 in the parentheses where you need to.
I'm a little confused on 5C.
5C.
I don't know why, but
Oh, well, I have a typo, but what can you say about the rate of the grade with increasing the amount of study time? So obviously, when you increase your study time, you're going to
you
see
get a better grade.
you're going to get a better grade. But when you
Yeah.
increase from what do you notice when you increase from 0 minutes to 80 minutes of studying compared to 80 minutes to 120 minutes of studying? Which interval
there's-
do you increase more, essentially?
The first one.
Yeah. Yeah, so I would just write that kind of similar to the caffeine, right? It's similar to how we wrote about that caffeine one.
Okay. Okay, cool. Thank you.
You're welcome.
For the units for 5, well, overall on number 5,
Mhm.
I meant actually no 2. Sorry, I was looking at the wrong number. I got the answers. I was just confused on how to word the units. Would it just be like the feet, like the height above the lake, like with the seconds after, or?
Yeah, you could just do feet per seconds.
Okay, thank you.
All right, I will take one last question, but then I have to go because I have to teach another class in 9 minutes.
Thank you.
You're welcome. Have a good week, or have a good day.
You too.
Thank you.
Thank you.
You're welcome. Have a good day.